In this lesson, we try to understand multiplication of numbers close to a 10, such as 7 or 8. For example, we'll find out 7 times 8 using some visuals and some smart arithmetic of daily shopping. Let's see how. Now we know this is a row rectangle that is 8 times as long but the same width as a unit little square. So it's a visual for 8. And in 7 times 8, we take 7 such row rectangles to form a rectangle. We know is a visual for 7 times 8 in the sense that the total number of smiley faces, one in each little square, which are contained in this rectangle, gives us 7 times 8. We see that every 8 is just 2 short of a full 10. We recognize that the rectangle representing 7 times 8 can be seen as a bigger rectangle, which is 7 times 10 minus the smaller rectangle of 2 times 7. Of course, we can also recognize this smaller rectangle as 7 times 2 or 2 times 7. Thus we see that 7 times 8 is simply 7 tens minus these 2 sevens. Now we of course know how to take away 2 times 7 from 7 tenths. We know 2 times 7 is 14 and 7 tenths minus 14 we can easily work out. But let's do it in a way that's a bit smart and as done in our day-to-day life. Let's compare this requirement of 7 tenths minus 2 times 7 with this scenario where we go to a market and in our purse we have just 7 10-rupee notes and nothing else. And we happen to make 2 purchases, each costing 7 rupees. A candy for 7 rupees. And then from the next shop, a cup of tea, which is also 7 rupees. Let's say our little kid purchases a candy for 7 rupees and we buy a cup of tea for 7 rupees from the next shop. Now what do? How do we pay 7 rupees for the candy and 7 rupees for a cup of tea from what we have with us in our purse? There aren't any 1 rupee coins or 1 rupee notes in our purse. The least that we have is a 10 rupee note. That doesn't bother us. To pay 7 rupees for the candy, we just give this 10 rupee note out to the shop fellow and the shop fellow would return us the 3 rupees. Because we know 10 is more than 7 by 3. So by giving 10 rupees to the shop fellow, we have given 3 rupees more than what we need to pay for the candy, which is 7 rupees. So the shop fellow gives us back the 3 rupees. And by this process, we would have effectively paid the shop person just the 7 rupees that is needed. And then to pay for the cup of tea, we repeat the same thing. We give the second 10 rupee note to tea shop and get back another 3 rupees. Now we represent this entire process here. See, these are the 7 tens that we originally had. And out of this, we have given a 10 rupee note 2 times. Or we have given out 2 tens. So minus 2 tens. But we would receive back 2 times 3 ones. And what we are left with in our purse is shown here. These are the 5 10 rupee notes that are left with us after we give away these 2 tens from the original 7 tens. And these are the 2 sets, each of 3 rupees that we got back into the purse. And therefore, we represent that by plus 2 times 3 ones. So thus we see 7 times 8 must be equal to 7 tenths minus 2 tenths plus 2 times 3 ones, or what is shown here. Of course, you know how to work it out, and I leave it to you. However, in this smart arithmetic, to figure out 7 times 8, we began by identifying that every 8 is just 2 short of a full 10. Every 8 is a 10 minus a 2. Therefore, 7 eighths should have 7 tenths minus 7 twos. We recognize that the rectangle representing 7 times 8 can be seen as a bigger rectangle, which is 7 times 10, minus the smaller rectangle of 2 times 7. And from there, these steps follow. We recognize that for 7 times 8, what we get as the final answer, 7 minus 2 tenths, that is 5 tenths, plus 2 threes, is exactly what we had learned by that magical method of crosses. But there we never gave any reasons why the number of tens should be given by the crosses 7 minus 2 or 8 minus 3, or why the ones are obtained by multiplying 3 and 2, and why we should add these ones to these tens. We just stated that. But here we know the reasons for every step that we have written here. Thus, you see, we have figured out how to work out 7 times 8, where 7 and 8 are both close to 10, through a smart arithmetic. A smart arithmetic that we use every day in our shopping.